Alright, I want to show you how to graph your basic cubic function, y equals x cubed, or you could call that f of x equals x cubed in function notation there. That's your basic run-of-the-mill cubic function, and the cubic functions will take this kind of shape where there's two critical points like that where it changes direction, and then the ends will go off into an infinity. So that's kind of what we're looking for, and we want to take this guy and graph something like that. And first thing to do is to create a table. I'm doing a horizontal one here. You can do a vertical one. Um, uh, I'm just doing a horizontal one because it's easier to fit on the screen here, so don't panic. So I've got some values of x to plug in here. We'll plug them into the function, see what output values we get, and then we'll plot those points. And I'm plotting. What am I plotting? Like 9 points here. You need quite a few points to get to the point where you see how the shape is going to go for a cubic function. When you're doing lines, you can plot 2 points, connect them, boom, you're done. With a cubic function, you want to put a few points in there so you get a good sense of the way it's going to look. So I'm going to plug these in and give yourself some negative values. Get 0 in there, something like that. So let's plug these in. So let's start with -4. So plug in -4 for x. So if I were to rewrite this term, I would do -4 cubed. So -4 cubed means -4 uh, times -4 times -4. Struggling to write that. That's a minus sign. Okay. So -4 times -4 is positive 16, and then times -4 is negative 64. So, and in general, you can keep in mind that if you have a negative number and you're raising it to a power that's an odd number, like 1 or 3 or 5, the result will be a negative number. So just heads up. And if it's an even number, it'll make it positive. So all right, so we've got -64 is our output there. So let's plug in -3. So this will be -3 cubed. So -3 times -3 is 9 times -3 is -27. Uh, -2 cubed is -2 times -2 times -2. -2 times -2 is 4 times -2 is 8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1 times 1 times 1, which is 1. 2 cubed is 2 times 2 is 4 times 2 is 8. 3 cubed is 27. And 4 cubed is apparently 1. Just kidding. It's 64. Okay, so that should be enough points. Let's plot those guys, see what happens. So when x is -4, y, or f of x, is -64. So, oh yeah, so I gave us a different scale here so we could fit these guys all on the coordinate plane here. So what I'm saying over here is that the on the x-axis, the lines represent 1. So no, 1, 2, 3, 4, or -1, -2, -3, -4. But then on the y-axis, I'm saying the lines represent jumps of 10, so that we're able to fit these on here. So 10, 20, 30, 40. So that's what that's about. All right, so -4, x is -4, so 1, 2, 3, 4, and then -64, so that's 10, 20, 30, 40, 50, 60, and then a little bit more. Let's say something like that. -3, 1, 2, 3, -27, 10, 20, a little bit more, not quite to the 30. Shift that over a little bit. -2, -8, so 1, 2 is -2, and then this would be -10, so -8 would not be quite that far, so I'm going to put it there. -1, -1, so we have -1, and then -1 on the y-axis would be, I don't know, just something roughly like that. 0, 0. That one's nice and easy, right on the origin. Line that up. 1, 1, so here's 1, and then, a little bit more. 2, 8, so 1, 2, and that would be 10, so not quite that far. It's not going to be exact, but it will give us a good idea. So 3, 27, 1, 2, 3, and then this is 10, 20, and some change. And 464. So 1, 2, 3, 4, and then 10, 20, 30, 40, 50, 60, and a little bit more, something like that. Okay, so you can kind of see these critical points, sort of where the graph changes direction, changes the direction again, and then these sides will go off into infinity. So that should be good enough to create the graph here. I'm going to connect these points. This might be a little sloppy. Let's see how it turns out. Alright, let's put arrows on the end to show that it goes to infinity both directions. Let's make it a color that you can see. How about blue? Let's make it thicker. Alright, so there is our graph of y equals x cubed. Pretty exciting. Yeah, kind of looks like a neon worm or something. Yeah, well, I hope you enjoy graphing cubic functions. Take care, and I'll see you next time.